Section 21.2, let's just fix the chair a bit. Section 21.2, page 313. These are the reciprocal functions I told you about. They're a wonderful shape. I mean, just look at this shape. This is question 1, and we're just going to read off the graph. So this is the graph of y equals 3 over x. The original one, the most basic one, is y equals 1 over x. And the characteristic shape is as follows. It's going to go something like that, like this one over here, and something like that. And trust me on this one, these two branches of the graph are in fact the same graph, but they never ever meet. We'll come on to that in the next question, but for now trust me on this one. Now the graph has been plotted for us. It's a lovely looking graph, a real pain to draw, and that's my example there of the most basic one. And here we've got the graph of y equals 3 over x. Straightforward really, and we've got to use the graph to find the solutions to these equations. X over 3 equals minus 2. So I've got the graph of y equals x over 3, and where does x over 3 equal minus 2? Answer, where it crosses the line y equals minus 2. So here I go. The line y equals minus 2 is right there, so let me just put it in quickly. Like that, say, label up. And there's one solution just there, and I'll read up like this. It won't let me. Oh good, done it. Minus 2 crosses there. I'll make that about minus 1.5, yeah? I reckon, one solution. So I've got here, again, y equals 2, that's what I want to use. Sorry, y equals minus 2, not done it yet. Oh, sorry. Y equals minus 2, one solution, it's minus 1.5. So I've got x equals minus 1.5. And here, next one, y equals 2, I need to plot in. So here we go, we'll do that now in red, if it lets me. Right, y equals 2. Bam, one solution again, as you can see. Yeah, done it. Y equals 2, one solution right there. I'll try to draw down from that point on, about there. Swap C, and there's solution 1.5, I reckon. So x equals 1.5 or 1.5. This is really hard, it's getting glitchy. And the next one, the last one, I've got x over 3 equals 0.5. In other words, I want to plot y equals 0.5. So it's straight across here like that. Let's try and do it now. So 0.5 is about here somewhere. Come right across and hit it. And of course it goes this way as well. Of course it does. But there's no solution on the left hand side. And I can see the solution is straight down there. And therefore that's going to be 6. So that's my line y equals 0.5. Totally invisible there, I know because it's blue on blue. But anyway, and x equals 6. Now let me just talk about this right now. Are these solutions sensible, acceptable, believable? Yes they are. Look at this. I've got y equals 3 over x, therefore I've got y times x equals 3. Straightforward, isn't it? And look at the shape of the graph. So pick two values that multiply together to make 3, for example. I don't know, 1 times 3. So I've got the point 1, 3. There's the point 1, 3 on the line right there. If I swap it round, 3 times 1, or if I make the y3 in the x1, I've got the point 1, 3. If I make the x value 3 in the y1, I've got the point 3, 1. And there it is right on the line, 3, 1. So if you carry on picking values of x and y to make 3, even use halves and 0.5s, and that explains why we get a solution of x equals 6, the last equation there. If you were to rearrange this and not use the graph, again you just cross multiply and you get 3 over minus 2 equals the x value they're looking for. And of course 3 divided by 2 is 1.5, so it's minus 1.5, so we've got it right. Look at this one here. I've got 3 over 2 equals x, just cross multiply again, and 3 divided by 2 you know is 1.5. And the next one, cross multiply again, swapping over the half and the x, 3 over a half is the x value they're looking for, and how many halves go into 3? Well, that's going to be 6 times, so x equals 6 is a believable solution. Now, part B is interesting. Explain why you cannot find a solution to x over 3 equals 0. Well, look, I've got the equation y equals 3 over x, and they want me to merge it with the line y equals 0. Alright? So, look, y equals 0, there's the x-axis. And as you can see very carefully, the x-axis did not cut either the top branch or the bottom branch. Neither will it ever cut through. Therefore, why can't you have a solution to 3 over x equals 0? Answer, the graph does not pass through This is really hard, it's not really working that well. Does not pass through the line y equals 0. If it doesn't do that, then there's not going to be any points or points of intersection. So that's it. It doesn't cut through y equals 0. And that's what you're asking me to do, and it can't be done. Alright, so that's an introduction to the reciprocal functions, or the 1 over x type graph. Let's just write it there. These are 1 over x type graphs, alright? Reciprocal graphs. Just write the word reciprocal there. How do you spell it? Reciprocal functions. Let's write the word here, functions or graphs. There you go, beautifully done. Right, that's that. Now, I think I've got another question ready to go. Just one. And there it is. Now, this is question 2, and this will be the last question here, because once you've plotted one of these, oh, it's just too long and boring to do too many. It says I'm given y equals 4 over x, as opposed to this one. Right, y equals 4 over x is a reciprocal function, and there's a spelling for us, so that helps. It says copy and complete the table of values for y equals 4 over x. Well, they're giving me from minus 20 all the way up to 20, going up in whatever spaces they say there. And as an example, I said y equals 4 over minus 20. I'm using the minus 20 as the first example there. So 4 divided by minus 20, I've got minus 0.2. So I've created the points minus 20, minus 0.2. That's that one. Another example, I did this one over here. I said y equals 4 over x, and I took the x value of 15. So I went 4 over 15 with my calculator and got 0.27. So therefore I've got the point 15, 0.27 for the y, and that's that. And I worked all the way across the table as shown there, worked out all the values and plotted them. Now I want to talk about this one here. This sign means infinity. Now you can't plot infinity on any size graph, even if it's an infinitely huge piece of paper. You still can't plot it, because look, I've got y equals 4 divided by x, and if x is 0, well, how many zeros go into 4? Well, billions and billions and billions. Remember, 0 is very small indeed, and therefore I can get loads of zeros to fit into 4. Can't be done. No. So the symbol for infinity is this, like 8 lying down on its side, like it was lazy or something. So that's the symbol for plot 0 along the x-axis and infinity up or infinity down. Doesn't happen. That is why there's a break in the graph. Look at it. Look what's happening here. Look at the y values. Minus 2, minus 2.7, minus 0.4. So it's getting less, smaller and smaller and smaller and smaller, and all of a sudden it disappears off to infinity. And then on the other side, 8, 4, 2, 0. So again, smaller and smaller and smaller and smaller. This is what we get here. So this is me plotting the graph, and I'll show you because it's really beautiful. Bang, there it is. I plot it on proper background paper. And it's really hard to do. Look, see? As your x value gets bigger and bigger and bigger and bigger and bigger, this graph comes closer and closer and closer and closer to the x-axis, but never, ever, ever, ever touches. And likewise, as x gets smaller and smaller and smaller and smaller towards 0, as you try and divide by 0, you're getting closer and closer and closer towards infinity, which is why the graph gets closer and closer to the y-axis, but never, ever, 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 ever touches it. If you get it to touch, you've done it wrong. So that's the best you can do. Then of course you start putting negative values in the equation. So y equals 4 over minus 6 or something. So we get exactly the same thing. We're approaching negative infinity here, and negative infinity there as well. So that's the graph you're going to get. I remember I told you when this started, the type of graph we're going to get is something like this, and they'll never touch. And I told you earlier that I'll be discussing why these two branches never connect, because we're playing with infinity in all the directions that we've got. Alright, so that's that. They don't touch. The graphs come as close as they can to the axis, and but won't ever reach 0. Alright? So let's see what the question is. So I've plotted all these lovely points, and I got that. So now what's the question? Right, use your graph to solve the following equations. So 4 over x equals 4. In other words, they want me to draw the line y equals 4. So let's just go blue. So y equals that, and y equals 4. Okay then, y equals 4. One solution right there. Let's just draw it in quickly in red. So bang, I don't really need all this, but I like using the facility. So that's line y equals 4, and there's one solution. Look right there, if I draw down like that, if it lets me, please let me, sort of, that's about that. So 2, 4, 6, that's about 1, isn't it? So roughly it's 1. Just one solution. Next one, 4 over x equals minus 3. So I'll plot the line y equals minus 3 essentially. So off we go, turn over, and x equals minus 3. So minus 2, minus 4, minus 3. So let's just draw it across there like that, and label it. And there's one solution up there. If I carefully draw up from there to there, not too beautiful. I'm trying very hard to make it actually work. What we got here? So that's minus 2, 4. It's about minus 1.6. I'm guessing that's minus 1 exactly. So it's minus. Again, on this graph, it's hard to tell. So minus 1 and a couple of squares. Minus 1.6. I'm going to go for. I'm not going to argue with it too much. So x equals minus 1 point, maybe 0.7. Yeah, minus 1.7. I'll show you why in a minute. And the last one, y equals 20, and actually let me rearrange it. Y equals 20, and 20 equals 4 over x. Yeah. So instead of putting the 20 on this side, as you'd expect, they put it on this side. Don't be confused by that. I've still got to draw the line y equals 20. See if I can do that. If I allowed for that. Y equals 20. Well, look, I've not drawn the line y equals 20. I mean, look, I'm off the scale there, so I'm not going to do that one. That's a stupid question, because look, my y values only go up to 8 and minus 8, so why are they even asking me that? But what I'm going to do, I'm going to cheat. Take a good look at this. I've got 4 over x equals 20, therefore x equals, and rearranging that one, that will be 4 over 20, and 4 over 20 is, I'm not sure really, goes in 5 times, equals a fifth, which equals 0.2. So when x equals 20, when y equals 20, x equals 0.2. Was it plottable? Y equals 20 is up here somewhere, 0.2. Well, there's 1, and 0.2 is about here, so I'd have to really come off the scale and draw it really close to the y-axis. It would be virtually unplottable, which is probably why they gave us tables of values that just go from that, they just produce results that go as much as minus 8 and plus 8 and no more. So it's a stupid question, but the solution is x equals 0.2. Now what about this one? Same thing, rearrange it. I'm not going to draw the line y equals minus 30 because it's really stupid and it's way off the scale. So I'm just going to do this. X equals 4 over minus 30. That will be 2 over 15. Let's just calculate it quickly. So 4 divided by negative 30, and that gives me minus 1.3333. It's a crazy solution anyway, isn't it? So minus 0.13 recurring, and you can never read this 1,3 off a graph anyway, not at the scale that I've got. And again, I choose the biggest scale I can with the graph paper that I've got. So these two solutions are really, really stupid. Bad planning on behalf of question 2, I have to say. Bad planning. These two are acceptable. And yeah, I'll stop there. That's all I did. I calculated all the y values based on the equation y equals 4 over x, substituted the x values into the equation, worked them all out individually, and I showed you what I did there, and I just divided, and that's it. And that gives us a graph looking something like that. Again, sorry there's too much red going on there, but it's basically that one and that one. Alright, so end of question 2. There's only 4 questions in the whole section, and that's enough. 2 out of the 4 is enough. Hope that's okay. See you later.